Hi, today I want to talk about chapter 3, the decisions, the relational operators. You guys all know about this, just briefly going over it because you had this in your previous course, just to see how is it going to apply to Python. So I'm going to quickly go over these steps. Uh, excuse me. So we're going to be looking at if statement. So what you know about the if statement already. So you should know about the if statement. If you don't, then they have some serious problem. So how do we do it in Python? So in Python, we do it a little different, meaning that we are going to have colon. So we're going to put the colon after the condition. So yes, we do have a if statement, we have a else statement, and then we're going to put the colon in it. One of the things that is going to happen when you're coming in from C++, and we are happy with putting semicolon all over the place, and then you might be putting some semicolon here. Another thing that you should not do that. Another thing that we have to be aware of it is space is very important to Python. So basically, indentation is the one that's using for the blocks. So when especially coming from C++, which a space doesn't have any meaning, here space has meaning. That means that if I indent something, that's going to be my block of code. So looking at this, I have an if statement. Of course, I'm going to put the colon in there at the end, otherwise it's not going to work. And then I'm going to indent it. Either you're going to put a tab, or if you have an IDE, if you push enter, it's going to go here. So we're going to line them up space-wise, so it knows this else belongs to this if. So the space does matter in Python. We talked about how to get the input from the user, and this is just an example of how we're going to do this. So I'm going to go to the next one. Let me move this out of my way. So we can create a compound statement, meaning to putting more things together. So if I have else, if else, and the if else, if else, if else, again, the space is the one that's going to define where we're going. So this if and else are related to each other because they are in a line. Usually we can use tab, or you want to use a space. They have to be lined up. So meaning that if you, for some reason, if you have one here and they are not lining up over here, we're going to have a problem. It's not going to like it. So everything has to line up over here. This is the way we're going to do the blocks in Python. Okay, and then of course, when I do indentation over here, that means this one, it belongs to this block of code. So this one belongs to this block of code. So this is the way that the Python works. So we can have more than one statement, that's fine. The key is the colon that we have to do. Now we have a shorthand way of doing the if-else statement, just like you had it in your C++. We have this if else in one sentence. So we put the true condition, then we put the if, we put the condition here, we put the else. So if this is correct, we're going to do this one. If it's not correct, we're going to do this one. So the condition is coming in the middle. So this is my condition. If this condition is correct, I am going to be doing this one. If it is false, then I'm going to be doing this one. So that's a shortcut for it. Almost every language has that. Uh, the operators, we have greater than equal. We do have not equal in Python, so we can use that one. What else? Not equal, just like what you have in C++. So not equal, equality. So there is a difference between equality and assignment. So when we say if floor is equal 13, just like your C++, you have to put two of them in there. We can check to a string to see if it's equal. We can check to see if two strings are not equal. So the comparison for the string. Uh, so it does start with checking the characters, and if the characters are all exactly the same thing, it's going to be equal. It's going to check against the ASCII table. So if the character is uppercase, the other one is lowercase, that's going to be a smaller. So the order matters, how we're going to put our operator, and we're going to be careful about that. This is the assignment. This is not, so this is the assignment. So we shouldn't be using that for comparing it. You cannot compare a string with number. So they have to be the same type for it to be able to compare it. So I think we talked about this, that your floating points are going to have some limits. We have a limit in our computers, and the floating points can go so far. And we have something called round off error. That means we're going to have some extra decimals that when it's round off, we're going to lose it and we cannot get it back. So if I come up and say, I'm going to get the square root of 2, but if I multiply the square root by square root, I'm not going to get the 2. It's never going to happen. So the reason for that, of course, is we might have some extra digit way on the end of it. And that's what happens when we are using decimal point. That we do have it in regular numbering too. If you divide 10 by 3 and you get the result and you multiply it by 3, you're not going to get the 10 back. So we got to figure out how to do this. One is not to check for the equality of decimal number at all. Two is we can figure out a way to make it smaller so we can compare it. So what we are talking about here is something called epsilon, which is a very, very small. So we say if we subtract them from each other and the absolute value of that is going to be less than epsilon, that means they are equal. So epsilon is defined as a very, very small number. So we can do this if you are checking for the equality. So instead of doing equal, we can do this. So this epsilon is defined here as 1 to the 1 times 1 times 10 to the power of negative 14. So very, very small number. So we say, you know what? I mean, you can define it whatever you want to do it, and that's the way we define constant in Python, if you remember it. So we say if the difference between these two are smaller than that, we just throw it. And we say we accept it as a equal. So we are using the ASCII table. So uppercase is smaller than lowercase. That's the way it is. So it's going to start from the first character, moving on to next ones. So if the first two characters are the same, it's going to go to the next one. If they are not the same, it's going to compare it, and it's going to say which one is smaller. We have that appendix A that's going to define the ASCII table. If you don't know about it, that's a good thing to look at it. So we do have precedence on the operator. It's just like the math that we have. So for these things that we are talking about over here, we are talking about that we're going to do the right side first, and then we assign it to the left side. We talked about this before. So if I am doing any kind of a comparison, it's going to do the calculation, and then it's going to compare it. So that's going to be basically part of order of operation. So addition, subtraction, multiplication, division is going to come before less than. We can have nested branches. You should know this by now. Your book is talking about hand tracing. So you should be able to sit down without the computer, follow the steps to be sure everything is okay. So we can put some numbers in there. We gotta do some kind of a testing. Again, we are using constants over here. We should use constant as much as possible. So any number that we have in our program, we're going to define it as a constant. Uh, so we're going to go through our program. We're going to keep checking. So at the beginning is 0 and 0. And as we move on throughout the program, what's going to happen, we can just trace it. So we have else if in Python, and it's called elif. That's else if. So if I have if, else if, else if. The reason that we want to use this else if the first condition is correct, if the first condition is true, we are not going to check the rest of them. So if I have a bunch of if statement, if the first, these are going to be, all of them going to be tested all the time. So no matter what happens, it's going to test it all the time. But if I do if, then if the first one is true, it's not going to check the rest of them. The last one is always going to be the else. And one of the things that we talked about in CS2 is if I am checking something here and I get to the next one, I shouldn't be comparing the same condition again. So if I'm checking to see if the age is greater than 21, on the next one, I shouldn't be checking to see. So if age greater than 21, I shouldn't be checking on the next one to see if age is greater than 21 and less than 30. All I have to do is just check for age less than 30, and that's going to just give me the, and basically on the second line, that means it's above 21 and less than 30. So that's the way it is. So what's wrong with this code? It's just checking all of them all the time. And even though if it's going to be greater than 8, it's going to check to see if it's greater than 7, and it's going to check to see if it's greater than 6. So basically, it's going to print all of these things. So if I have 10, it's going to print this one, it's going to print this one, it's going to print this one, it's going to print all. Your book is talking about the flow charting. We should have done it in our early courses. I like it because it's a visual way. I have worked in the companies that we put big whiteboards and we're putting all the things out there. But we are not going to do too much of this. If you like to do it and you want to do it, you are a visual person, it would be nice to have it. So we would start from a position. We have a condition. If it's true, we're going to do this one. If it's false, we're going to do this one. And if you have multi branches, this is the way it's going to happen. If it's true, we're going to do this. If it's false, we're going to check the second one, and so on and so forth. So whenever we are building any program, we're going to be creating some test cases. And so that's going to be part of our design. We're going to do a full project design later on in the course. And part of it is to create test cases. How do we test these things? Okay, so next topic is about the Boolean variables. You should know about Boolean. Maybe we didn't practice enough in previous course, but Boolean is condition is going to be true or false. And then we are going to be adding and an or to it to create more conditions. So you should know about this. When we have and, both of them have to be true, otherwise it's going to be false. So first condition, second condition. So here, if I say if 10 greater than 0 and 10 less than 100, they both have to be true for the whole thing to be true. Otherwise, it's going to be false. And the or, everything is going to be true. The only time it's false if both of them are false. You should know that. So here, we're using the word or and the lowercase. We have not, that's going to make it opposite. It's going to make it a little weird to add not to and or. There is a formula that if you have a not, it's going to apply. So if you have a not in front of the and, it's going to change it to or. So if I have not A and B, it's the same as not A or not B. We can spend some time on this if you're not familiar with it. So the inequality, we're going to be using that one. So remember, we had this one also in CSS2. So if it's going to be able to decide at the first condition, it's not going to check the second condition. So for the and, if the first one is false, I don't need to check the second one. I already know the whole thing is going to be false. So that's what the short circuit is over here, short circuit. For the or, if the first one is true, we know the whole thing is going to be true. I don't need to check the second. So this is the De Morgan law that I was talking about. So when you put the not at the beginning, you can apply to the whole thing. So one way of using not is you build your opposite condition and you put the not in front of it. So I'm going to say the country equal USA or a state is AK, or a state is HI, and then I put the not in front of it. Or I can just put the not after each one of them. But you got to keep in mind that if I apply this not inside, then it's going to be and. So my or is going to be changed to and vice versa. In here, we're going to be talking about the strings. The strings, we have a little different things in a string that we had it in CS2 or C++. We can check to see if a substring is inside the string. So when we are checking to see if way is in name, it's going to go in the name. If this one is in there, it's going to return true. And I can say not in. So I'm checking a substring inside a string. We have something called ends with. So I can check to see if my string is ending with something. So that's the method called ends with. Again, all of these things are coming from the class string. So we're checking to see if a substring is inside another one. We can count it to see the number of non-overlapping occurrences of substring. We can check it to see if it ends with. We can find a substring in the string. So if it does find it, it's going to return. And if it doesn't find it, it's going to return a -1. If it finds it, it's going to give it a position. And we can check to see if it's starting with something. So I can check to see if it's ending or starting with something. We can check it to see if it's alphanumeric, if it's alpha or it's digit. So I can check my string to see if it has a combination of these things. I can check it to see if it's a lower a space or if it's upper. So I can check that. So we do have equality. We can check the equality. Remember, uppercase, lowercase does matter. So the capital is smaller than lowercase. We can check to see if the substring is inside of the other one by doing in. With not in, if we're checking to see if it's not. We can check to see how many of these do I have. I can check to see if the substring does exist in this string. Starts with is a space, is digit. So from this point on, we're going to do validation on our strings, I mean input. So whenever we're getting an input, we have to check or validate our input. We have to do that for two reasons. One is the computers are not unlimited space, so we cannot just put everything in there. But the main reason is if I have a bad data, and if I have the customer, maybe I can ask the customer again for the data, or I can do something about the data. I shouldn't be running the whole program and with the bad data. That's the bottom line. So if I have a bad data, I want to get it at the beginning. So in this case, if the floor is 13, we don't have floor 13. So it goes from 12 to 14. But we should have a limit, meaning that not only we don't have floor 13, we cannot go higher than 20 or lower than 0. So if I ask somebody for a floor number, if they give me 13, I get negative number, or anything greater than 20, those are bad numbers. So I have to check those things. So when I get the floor number, I'm going to be checking. And if that is not correct, I'm going to write some kind of a error message, and we can actually run this till we get the correct one. For now, we're just going to get the. Remember, this book was created for CS2 students, so it was assuming that you don't have no background in programming. So that's where we're getting. So that is chapter 3 with the if statements.